So thanks very much. Great presentation just now. I think the context of what I'm presenting here matches exactly what Daniel just showed, which is great because I don't need to repeat it in a very short slot. But I am going to take a different perspective. So I am two people today. I am both the Chief Technology Officer of a business that provides a platform for DLT-based data assurance for critical asset management and supply chains. And I am also the chair of the Digital Twin Consortium Security and Trustworthiness Working Group. So there's a huge amount of overlap in the kind of background of what I've done and what Daniel just presented, but coming together for a slightly different end here with digital twins. So this is the business track. We want to know how we can drive better business, and McKinsey like to think they can tell people that. Linking up the physical and digital worlds, which is basically everything that digital twin does, could generate $11 trillion a year in economic value in the very near future. But that's if businesses get it right. So what we see, of course, if you take a sort of security or risk perspective, is that we have this thing called digital transformation. Digital transformation has started to recognize the value of digital twins, but that does bring new risks through the cybersecurity supply chain. And as I'm sure we're about to hear from our friends at UCL who are up next, DLT is great for supply chains, and the security of digital twins is also a supply chain. But it's a little bit different because it's not just a sort of day one delivery of physical stuff. It's actually a continuous delivery of all kinds of things. It's sensor data, it's new threats, it's new risks, it's new components coming and going all the time, it's updates. And so while the model and the metaphor fits, the speed and scale is tremendously different when it comes to digital operations. And so what this comes down to really is whether you can trust your partner's data. If you're getting delivered data through this supply chain into your digital twins, into your digital operations, second after second, how do you use that to make decisions and change your models and do business, expose yourself to risk, frankly, without knowing very keenly where it came from? So just as in a sort of regular physical supply chain, people worry about where did my stuff come from, and has the box been damaged, and has it been below 15 degrees for its entire travel. You have the same issues with digital operations. You have different people in the supply chain with different concerns, different levels of responsibility, and all of these people need to know that their risk and their responsibility and their contractual obligations are covered if they're going to accept digital twins and blockchains and all of these fancy technologies into their mainline business, if they're actually going to risk their insurance policy or their operating license on this stuff. So how does blockchain help with that? Well, an awful lot of the certainty and trust that people have in today's supply chain operations really comes from paper documents, long static processes, and so on. And we all know this. We all love blockchain, so we all know about how blockchain can replace paper. But the important thing is that it's very difficult to move in a real operating business when you've got real serious industrial risk at hand if you don't have the paperwork and the audits and the assurance to back up what you did. And I think it was okay is not an excuse if in this particular industry a building falls down 10 years after it was built, right? You have to have the proof that it was okay, or at least the proof that you really thought it was okay. And so what we do with blockchain, standard thing, prove who did what when by recording it on the chain. That can then build up a sort of life history. And crucially, a shared life history that everybody can see and everybody sees the same one. So to the question that was just asked about, what's the unique benefit of blockchain? Obviously, there isn't a unique benefit of blockchain, there never is. But the fact that everybody sees the same operating data at the same time and it can't be revoked means that you get that end-to-end assurance much more quickly. So you know that if something's delivered to you, whether it's a digital good or a physical good, you know that you've got that record right here, right now, forever. It can't be shredded, it can't be taken away, it can't be lost later. And so your operating assurance is guaranteed. And you know that everybody else who's watching, like your suppliers and your partners and your insurance company, all also have that same view of the world. So you're kind of safe in that sense. And that turns this sort of complex, unscalable mess into something which is actually verifiable and trustworthy enough to satisfy business stakeholders. Because again, everything I've said here is really basic stuff for people in blockchain space. This is just what we do, but we have to remember that when you move into a real business, those are different people. They have different risk appetite, and they have a different level of proof that they need in order to take a risk, and that's where we meet in the middle. So bearing in mind, trust is not the same as security. Trust is actually, again, more about this sort of slightly subjective risk measure. So I don't care how good your crypto is, I want to know if it's going to stand up in a court of law. And in digital twins in particular, what this means is that I don't care how good your crypto was on day one, I care how good it is right now. So we're starting to see a move, and where blockchain and digital twin are starting to see some nice convergence is we're seeing a move from things being tested on day one against a static checklist to being verified every minute, every second of every day against a dynamic risk status. And this is because we've come to realize over the years that software is not secure, and environments change and regulations change and the economics of risk change all the time. And you've got to be making your judgments based on that, not based on what your ISO audit told you 3 years ago. So in the words of the great Jon Geater, things are only impossible until they're not. Well, in digital operations, things are only trustworthy until they're not. And it's really basically impossible to tell what it is that's going to change those economics of trust, whether it's a change in regulations or whether it's a change in technology or whether it's a change in law. You can't foresee that on the timescales of industry or manufacturing or construction, which lasts for 15, 25, maybe even longer than that. I've got some business in the nuclear industry, and they're talking about thousands of years. Well, who knows what we need to store or check or verify for thousands of years of operation. But one of the things for sure, you can't do it based on a static checklist. So instead, what we're looking to do in the model in the Digital Twin Consortium, as well as in my business, is to enable all of these business stakeholders to make their decisions in context in real time. So with what I've got absolutely right now, with what I'm trying to do absolutely right now against the standards of right now, what's the smartest decision I can make, or what's the smartest automation that my digital twin can make based on everything I know. So we're actually building something. The Digital Twin Consortium has a conference. It's a little bit of a plug for the DTC, but it's worth doing. We have a conference in December where we're going to show some of this in action using a variety of technologies, but including digital distributed ledgers, to add dynamic safety to a manufacturing twin. So and the sort of thing that we're looking to do with this is to model dynamic situations. So I have moving machines, I've got automated vehicles, I've got some smart manufacturing static machines, I've got some environmental sensors, and I have humans, and humans are not, as far as we understand, smart in that sense, but they are quite vulnerable, and you want to avoid damaging them. And what we can do by applying this very high trust model of using continuous assurance, as we call it, of data transfer, of data provenance, of the security patches and safety condition of each individual element of the digital twin, we're able to actually build up a much better picture and a much better decision-making engine than is possible with sort of traditional safety techniques, which are based on safe by design, proven in use, or checkbox type methods. And of course, again, if you take one simple view of automation or artificial intelligence or whatever, this kind of data-driven context-aware decision-making is kind of obvious. Everybody knows, but if everybody knows that, why doesn't it work today? Well, because we need all of these things to come together. You can't just have data-driven decisions. It has to be trustworthy data. And you can't just have automation out of context. You have to have automation within a business. And so bringing all three of these things together in order to allow dynamic safety assessments is really important. And that missing link seems to have been the data assurance, which we're working on now with the benefit of distributed ledgers. So quick conclusions on this. Static assurance, especially in construction, we've just seen it in Daniel's presentation. You've got loads and loads of complex systems of systems. There is absolutely no way you can tell in advance what could go wrong and what you should do about that. So static assurance cases are simply not fit for purpose. They never really were, and they definitely aren't once you add digital operations, digital twins, and automation to your physical processes. And so we need to move to a world of dynamic assurance cases, which are outcome-based. So it's not things like put on the brakes, but it's things like don't hit the person in a decision tree. We need to move to that kind of model. And the only way that you can do that is firstly by having enough context data and enough of a model to check the current context. That's what the digital twin does. And then secondly, to make sure the data and the model and the context that you're working on is trustworthy and has a level of provenance that a business and an insurance company, or heaven forfend, a court of law, would be interested in looking at. And that's where DLT and data assurance comes from. And if we do that and bring them together properly, then we can have trusted twins or trusted construction or trusted infrastructure, however you want to apply it. There you go. That's the quickest I can do those slides. But yeah, it's the confluence. If one thing to say, this community knows part of the picture, the AI community knows part of the picture, the digital twin community knows part of the picture, we're only going to get anywhere if we bring them all together. So more cross collaboration is what we need.
Thank you very much for the presentation, Jon. It's just a quick question. So we have a question here in our Q&A panel from Alistair. So he says, thank you, Jon, great presentation. Regarding shared asset history, what barriers do you see to stakeholders adopting an open system in light of commercial sensitivities and the potential value of what systems data to third parties who may have added to no data in the actual delivery and maintenance of a given asset through the system?
There are two main angles that I see to that answer. One is that the system and the data, I think, as you identify, Alistair, are different. So open software has no commercial sensitivity at all. It's only the data running through it that does. When you look at those problems, the idea of being sort of commercially sensitive or secretive are inseparable from things like antitrust and non-competitive operations, because once you get into these complex systems, you have lots of competitors, vendors, suppliers, whoever, all interoperating within this wider context. And so it's necessary to have some level of confidentiality anyway, right? So if you're bidding on a construction project, you can't have, open bidding or price fixing are generally frowned upon. So there are techniques for sort of confidential transactions on blockchain. There are techniques for compartmentalizing data, which are widely in use in the digital twin platforms, and that's how you deal with it. So I think open software for interoperability is absolutely vital. Open data it would be nice, but it's less vital. We can get started without it.
Thank you for this, Jon. So may I follow up on that? So based on your work and the findings and so on, so would you say that stakeholders are a bit worried about different types of blockchain, private, public, and so on? Do they worry about this sort of concepts, and how does it tie with your previous response about open source?
Yeah, they absolutely do. So another thing, again, because this is a business track, it's worth mentioning that almost all of my business is in the sensitive industries. We do quite a lot in both the UK and the US and in Canada. We have some work in the nuclear industry, and they're obviously very sensitive, and they are nationally sensitive. So we get questions about sort of sovereignty of data. And this isn't even necessarily an IT security question. It's a legal requirement that that data not leave the UK or not leave the US. You just can't negotiate it. So, so yeah, they do have those concerns, but actually they tend to be people who already have a huge problem, right? Of some kind of, their operations are just too slow, or they're too expensive, or they're too sensitive, and they really need to solve that problem. And then the questions don't really come from a point of view of how's your public blockchain or where are your smart contracts. They tend to be more sort of practical, simple questions about how do I protect the logins and where is the data residing. So it actually turns into quite ordinary IT supplier type questions. But ultimately, yes, they would care if they knew the details. They would absolutely care about that.
Okay, great. Thank you very much for your time. Thank you very much for the presentation and answering our questions.